What is delta omega? Delta omega is defined as mean angular speed of particle about O in what time? In an interval of time delta t. Please write it down. Delta omega is defined as mean angular speed of particle, but just mean angular speed will not suffice. Clear, yeah? Just
Yes,
mean
sir.
angular speed is not sufficient. It is not to suffice. We need to know in its totality. And what is it known in its totality? Mean angular speed of particle about O in an interval of time delta t. Am I clear?
Yes, sir.
Yes, sir.
And in this interval, what angle was negotiated? Delta theta, correct?
Yes, sir.
If we find ratio of delta theta to delta t, if we find ratio of delta theta to delta t, what we get? We get whatever we have defined. Now that definition got a mathematical articulation. Can we say that?
Yes,
Yes,
sir.
sir.
What we have defined, it got a mathematical articulation. Correct? Yeah. This is
Yes,
the
sir.
mathematics behind of delta omega.
Yes, sir.
Having said that, generally they don't define in so many words. Clear? Yeah.
Yes,
Yes,
sir.
sir.
Generally,
Yes,
they
sir.
don't define in so many words. Generally, they are to say just mean angular speed. Fine.
Yes, sir.
Yes.
Yes, sir.
You know what in exact it should be. Fine, yeah.
Yes, sir.
Yes, sir.
It is angular displacement to time taken for the same. And this is average or mean to me. Average or mean about what point O? An average or mean calculated in what span of time? Delta T.
T.
Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now what I'm to ask you is, let us read the same, but under a rider. And the rider being limit delta t is tending to 0. This is a rider now. So I am reading for average or mean, but it comes with a rider. And what is that rider? Delta t is tending to 0. Am I clear?
Yes, sir.
Yes, sir.
The moment I say delta t is changing or tending to 0, I am suggestive of there being no time span rendered to the particle. Fine.
Yes,
I'm
sir.
not rendering any time interval to the particle. Correct, yeah?
Yes, sir.
Yes, sir.
And if I'm not rendering any time interval to the particle, then the average, which is what I was calculating initially, I told you mean or average, correct?
Yes, sir.
And the average will now, for delta t tending to 0, will change to anyone.
So DT.
To 0. It is no more average. For average, you have to have a span, correct? Yeah.
So it'll become instantaneous. It'll become DT.
Delta t tending to 0, Krish. I'm not referring to a span. I'm referring to a span, if at all I am. I'm referring to a span which is insignificant, right, Krish?
Yes, sir.
Yes, sir.
From average, we are transcending the average limit and going beyond it. We are now to say we are reading the situation for that instant, correct?
Yes, sir.
Yes, sir.
Yes, sir.
From average to instant. This is our journey, correct, dear? And this journey
Yes.
we do undertake with mathematical operation. What that being, I think Krish will be able to relate to it. What that being, limit delta t is tending to 0. For others, it is just that delta t is tending to 0. Correct, yeah?
Yes, sir.
Okay, so if delta t will tend to 0, see for yourself. Will you not get back to point P? Will
Yes,
you
sir.
or not?
Yes.
Yes,
So
sir.
we are back to point P. Why? Because delta t is tending to 0. And then the symbol used for the same is omega. This omega will relate to which point? P or P prime. Quickly. This omega will relate to which point? Quickly, please.
So, P.
So
P.
P.
Correct? Yeah? This
Yes,
omega will
sir.
relate to P. It may be changing, may be same. I'm not going there. I'm asking you a question based on what you're understanding. This omega will relate to P. Correct? Yeah?
Yes, sir.
Yes, sir.
Okay, so firstly we define what is average. Then from average we went over to go to the instantaneous value calculation. Now with instantaneous value calculation, we are going a step further, and what I am to now include is this term omega, which we are reading angular speed for now, or instantaneous angular speed for now, is in actual a vector quantity. Is in actual a vector quantity. Is it okay? So I'm taking in piecemeal. First delta omega, and then from delta omega to omega. Omega, when was known to me, we were known to it being instantaneous. Therefore, it a scalar quantity, and we named it in accordance. It is angular speed. Of course, angular speed alone doesn't suffice. You know that very well. So to get in totality the name, we are to define it as angular speed about O at t equal to t. Getting it?
Yes, sir.
Getting it? Now there
Yes,
is
sir.
no span. Are you getting it? So
Yes,
angular speed of particle about O remains same. But previously we were reading against a span, correct?
yes, sir.
Yes,
Now
sir.
what will I say? At t equal to t, correct? Yeah.
Yes, sir.
Yes, sir.
That is angular speed definition. And then we went beyond it. We added a unit vector to angular speed. We are, or you are rather, you are then incumbent on and ask. It's imperative of you to ask me, how can we allocate vector to omega? What is the methodology? I'll ask you to take a right hand screw. Is it okay, dear? I'll ask you to take a right hand screw and rotate it in the sense of movement of the particle taken. Is it okay?
Yes, sir.
Rotate it in the sense of movement of the particle taken. What is the sense of movement of particle? Anti-clockwise. Correct?
Anti-clockwise. Yes,
Yes,
sir.
sir.
So when I take right hand screw, or if I have to curl my fingers, when I curl my fingers anti-clockwise, thumb will indicate the direction of omega. Correct? Yeah.
Sir.
Yes, sir.
Yes, sir.
That is the methodology. If this is x to me, this y, then we can write omega vectorially as omega into k prime, right? Yeah.
Mm,
Yes, sir.
Yes,
yes,
sir.
sir.
Okay, so this is the definition for angular velocity. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, having said that, when we are to study for circular motion, we wish find two quantities. Remember, whosoever says let us study for circular motion today, he is indicative of findings V and A. He is indicative of findings V and A. What are they? Velocity and acceleration. Find here.
Yes, sir.
Yes, sir.
Yes, sir.
To find velocity and acceleration, I define two unit vectors. I take two unit vectors, and they are in which direction? I am showing you over here. One is in this direction. This is marked UR. I think I am visible. If not, tell me please.
So
No,
visible.
sir. Yes,
Not
sir.
visible?
Just
No. Okay. Because I wanted to distinguish. So try my other chalk piece. Check, is it now visible, Krish?
yeah, it's better, sir.
Or
So
Yes,
yeah,
sir.
the UR is not visible. UR,
you
the
are. This
letters.
is you are. Just write you are. You with a
Yeah.
subscript are, right, Krish?
Yes, sir.
And this one is u theta. Is it okay? Visible, Krish?
Yes, sir. Yes, sir.
So u r and u theta. Visible to all of you?
Yes, sir.
Okay. What are they? Unit vectors. Clear, yeah?
Yes.
Yes, sir.
Yes, sir.
They unit vectors. Okay, and one more important, very important point. You all are with different institutes also running your courses. So please, at any point in time, don't have any inhibition or any hiccup in asking any question related to whatever is an institute running. I will take right here in the class itself. Am I clear? It is not
Yes,
that
sir.
I'm asking you to ask only with whatever is running over here. You are open to ask and you will get all support for your coaching as well as school. Clear, dear? Because they are not to run in tandem. We know that very well. Okay? Everyone, of course, will try to impress upon their own syllabus. So we are not going into any quarreling mode. You go with them and you come up with your doubt related to their portion as well. We'll take it in class itself. Fine, dear?
Yes,
Yes,
sir.
sir.
Yes.
Your theory. Okay? That is
Yes,
an
sir.
additional
Yes,
help
sir.
that I'll be trying to tender from my end. Fine, dear?
Yes,
Yeah.
sir.
Okay. So this is UR, U theta given to us. Now, we wish find or write U r in terms of theta. And why I'm asking you, you'll get to know in few seconds from now. For now, just adhere to what being asked. Write UR in terms of I cap and J cap. So how can we write for any vector? Magnitude of that vector, cos of the angle that that vector is making with x-axis into I cap. Remember, yeah? And you
Yes, sir.
recollect magnitude of the vector again into cos of the other angle will be 90 minus alpha, which can be written as sine theta. Right here into j
A
cap.
cap. Yes, sir.
Okay, so UR is this to me, and mod of UR will be 1. Why? Because UR is a unit vector, correct? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
What we end up getting? Cos of the angle theta I cap plus sine of the angle theta j cap, correct?
Yes, sir.
Sine of the angle theta j cap. Please endorse. Find here, all of you.
Yes, sir.
Yes, sir.
Okay, good enough. Next, I ask you on u theta. What will be u theta mark? U theta is again a unit vector, but we want it to be presented in I cap and j cap. And I told you why, you'll get to know in few seconds from now. U theta the mod into. Now think of what u theta is making. I'm extending it for you. This is 90, correct? Yeah. Tangent
Yes,
and
sir.
radius. And in this triangle, exterior angle will be therefore 90 plus theta, correct? Yeah. This is known to you, property of triangle.
Yes, sir.
All of
Yes,
you,
sir. Yes, sir.
Yes, sir.
90 plus theta, correct? Yeah. Adesh.
Yes. Yes, sir.
Okay. So what shall I write? Cos of the angle 90 plus theta into I cap plus mod of u theta, correct? Yeah.
Yes, sir.
Into
Yes,
Yes,
sir.
sir.
of the angle 90 plus, what shall I write? 90 cos, na? Cos
Yes, sir.
90 plus theta. And then sine of the angle 90 plus theta, correct? Check
Yes, sir.
once.
Yeah, yeah. So 1 second.
Check it. Check it.
Yes, sir.
Yes, sir. Yes, sir.
It's fine.
Yes, sir.
Yes.
Okay. Now, what is mod of u theta? Mod of u theta is 1. Correct, yeah?
So one small doubt.
Yeah, dear.
So would it be all right if I took the vector onto the axis?
Yeah, you can. You want to
Then I
break
guess
this way?
because according to me, yes, so here will be
Yeah. It'll
90
be the
minus.
same.
So there will be theta, no, sir, the upward direction. Won't be sine theta in the upward
Again,
direction.
cos, yeah.
Okay. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Got it. Whichever way you deem, dear, whichever way is to u conversion, go by that. No issue.
Yes,
You can mark this as theta. This will be theta, of course. It will be theta. Correct, dear. Correct, Krish?
yes,
And
yes,
then
sir.
you will be getting whatever I am to now simplify this to. Correct?
Yes, sir. It's the same.
U theta is 1 and cos 90 plus theta. Cos 90 plus theta will be minus of sine theta. Correct, dear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what do we get u theta right over here? What do we get u theta to be in terms of I cap and j cap is minus of sine theta I cap, correct?
Yes, sir.
Yes, sir.
Then mod again 1 sine 90 plus theta is just cos theta, correct?
Yes,
Yes,
sir.
sir.
So plus of cos theta into j cap. Find yeah.
Yes, sir.
Yes,
Please
sir.
check, all of you. Got it?
Yes,
Yes,
sir.
sir.
So you know now u r and u theta in terms of I cap and j cap. Clear, dear?
Yes,
Yes.
sir.
Yes, sir.
Okay. Please keep it intact somewhere. I'll be asking you later. For now, I make some space for myself. Fine, dear?
Yes, sir.
Yes, sir.
Okay. Now back to what our intention is. I have told you that whosoever is to take this topic, he will ask you to eventuate with velocity and acceleration. Correct, yeah?
Yes, sir.
So in keeping with what I did say, let me ask you, can I write velocity over here as dr by dt? Can we write
Yes, sir.
velocity
Yes,
as
sir.
dr by dt? That is what is definition to it. Correct, yeah?
Yes, sir.
Yes, sir.
dr by correct, yeah? Yes, Krish?
Yes, sir. Yes, sir.
Okay. And also as per the figure that you do have, r is nothing but mod of r into ur. A vector is nothing but magnitude multiplied with unit vector in that direction. Correct?
Yes, sir.
Yes, sir.
Correct, yeah? So
Yes,
R
sir.
vector. What is R vector to me? I draw over here. What is R vector to me? This is R vector to me, correct?
Yes, sir.
Yes, sir.
This is R vector. Clear, yeah? And R vector can be
Yes.
written as magnitude of R, which is radius.
Yes, sir.
Yes,
Magnitude
sir.
of R, which is radius. Correct, yeah? This small r is radius. Correct, yeah?
Yes,
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 sir.
sir.
And UR is the unit vector in this direction. Find, yeah? Any
Yes,
point
Yes,
with
sir.
this equation? Anyone?
No, sir.
No, sir.
Okay. Then V we write as now d r u r by dt. You can write UR with cap, you can write UR with bar, no issue. Is it okay? You can write with cap as well. Find yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Here, as R is constant, can I take it out of differentiation symbol?
Yes, sir.
Yes, sir.
Oh, and then dur by dt. dur by dt, correct?
Yes, sir.
And what did we find for ur? We found that ur is nothing but cos theta I cap plus sine theta j cap. Find ya?
Yes, sir.
Yes, sir.
We also did find that u theta is nothing but minus of cos theta I cap. Correct?
No, sir. The
Yes,
minus
sir.
of sine theta I cap.
Sin theta I cap plus cos theta j cap. Correct?
Yes, sir.
Okay.
Yes, sir.
So minus of sine theta I cap plus of cos theta j cap. Now I wish any one of you get me the differentiation required here. That is, I wish to differentiate UR with time. Okay? And when you do so, please see for yourself. Cos theta cannot be differentiated directly with time, correct?
Yes, sir.
Why?
Yes, sir.
It is function of theta, correct, dear?
Yes, sir.
Yes, sir. So we change rule.
Created with respect to theta and then theta with time, right, dear?
Yes, sir.
Yes, sir.
This is what is called chain rule, right, dear?
Yes, sir.
Okay, shall we differentiate it then? Cos theta differentiation will get me minus of sine theta
Yes, sir.
and I cap as it is. It is the method of differentiation, vector differentiation. And then d theta by dt I'll take common. Find here.
Yes, sir.
Yes, sir.
Next is differentiation of sine theta, which is to get you cos theta, correct here?
We'll be getting
Yes,
U
sir.
theta inside. Yeah.
Into j cap, correct here? Yeah.
Yes, sir.
Yes.
Into j cap. Now, whole multiplied with d theta by dt. Find here.
Yes, sir.
Yes, sir.
Have space you can write. I don't have, so I am keeping it as it is. Find here. Whole should be multiplied
Yes, sir.
with d theta by dt, correct?
Yes, sir.
Yes, sir.
And then the term which is in parenthesis is nothing but u theta, correct here?
Yes,
Yes,
sir.
sir.
Keep for yourself. This is nothing but u theta, correct?
Yeah, yeah, yes, sir.
Yes, sir.
What is u theta into d theta by dt? Find here.
Yes, sir.
Yes, sir.
Theta into d theta by dt. Let me make the replacement here then. R as it is, dur by dt is nothing but u theta into d theta by dt. We can change the order, no issue. Correct here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. And you have defined d theta by dt as instantaneous angular speed. Correct here?
Yes, sir.
As instantaneous angular speed or simply angular speed about O at t equal to t, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
I'm making good of the symbol omega. This is to get you r omega u theta. Please see for yourself, class. We got V now. We got V now. Correct? V is equal to what to us? R omega into u theta. If I am
Yes,
to
sir.
only find magnitude, then V will be equal to R omega. This is the equation I've been harping for long. Is it clear now?
Yes,
Yes,
sir.
Anish Vedant?
Yes,
Yes,
sir.
sir.
If I take magnitude, u theta will get me 1. It will lead me to V is equal to R omega. What is V over here? Linear speed. Clear?
Yes, sir.
yes,
Yes.
sir.
What is V over here? Linear speed. And what omega? Angular speed. What is R? Of course, radius.
Yes,
Yes,
sir.
sir.
Am I clear with this notation?
Yes,
Yes,
sir.
Okay. Also, vectorially, if you want, can be shaped this equation to omega cross R. You can write it as omega cross R vectorially because omega is out of the plane, correct here?
Yes, sir.
Yes, sir.
And R is this to us. We can transport them, bring over here. This is omega and this R right here.
Yes,
Bring
sir.
the
Yes,
tails together, getting it.
Yes,
Yes,
sir.
sir.
And then turn omega towards R. Omega cross R, getting it?
Yes, sir.
Yes, sir.
Getting it, turning of the finger, getting it or not? Omega cross R, getting it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now the new direction of velocity, right?
Yes, sir.
Right.
So V vectorially can also be marked omega cross R. This is about velocity. Clear, class?
Yes, sir.
Yes, sir.
Okay, once done, let's transcend and go for acceleration hunt. Let us try to find acceleration right now. As V vector, as V vector can be expressed in terms of u theta as v vector can be expressed in terms of u theta. Now see for yourself how I'm expressing it. Is it okay? Can we write it down this way?
Yes, sir.
Yes, sir.
Let us differentiate v to get acceleration. Let us differentiate v to get acceleration. Of course, differentiation with time, right, class?
Yes, sir.
Yes, sir.
Now here you need to exercise caution. If you look for the previous equation, we were unflinchingly, u theta first I wrote, and unflinchingly without caring much took r out of differentiation, owing to r being constant, right dear?
Yes, sir.
Yes, sir.
Here we can't exercise the same. Why can't we exercise the same? Because a particle can negotiate circular track with variable speed, correct?
Yes, sir.
I cannot say speed of the particle is ought to be same. If the particle is in a circle, the radius must be fixed. That we know, correct? Yeah.
Yes.
Yes.
Yes, sir.
And we impose our thoughts, keeping speed constant. As we are open to variable speed, in this case, both v and u theta are to change with time or may change with time, correct?
Yes, sir.
U theta is certainly to change with time. V we can have a say on. For now, I'm saying that speed is also changing with time. Fine, dear? Why?
Yes.
Because I want to get no specific result. I want to get amorphous result. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So we will differentiate it following methodology of product rule, right, dear? So V
Yes, sir.
as it is du theta by dt. Are you known to product rule or does the other does?
So known to product rule.
Yes, sir.
Into
Known.
V rule.
Yes, sir.
Okay, known to all of you, yes or no?
Yes,
Yes.
sir. Yes, sir.
Okay, so V as it is differentiation of u theta. Then differentiation of V u theta as it is. Correct, dear?
Yes, sir.
Yes.
Okay, good enough. Now, this I don't have any problem. You know why I don't have problem with this? I know its direction, correct?
Yes, sir.
In u theta direction, so I don't have any problem with that factor. Certainly, I do have with this because this is not getting me this is something abstract. I'm not able to from here comprehend in which direction it is. So if I'm not able to comprehend in which direction it is, I'll try to bring it to my comprehension level, and that we can do easily by differentiating u theta. I write u theta again for you. U theta was what to us? Minus of sine theta I cap plus of cos theta j cap. Correct, dear?
Yes, sir.
Yes, sir.
Let us differentiate it with respect to time. Why? Because I am not able to get a clear picture on du theta by dt vis-a-vis direction. So I want to clear air over it. And how can I clear over it? By using du theta by dt. Is it okay?
Yes, sir.
So when
Yes,
I'm
sir.
to clear air over it, what I get to see is this will be minus of cos theta I cap and this minus of sine theta j cap into d theta by dt, right? Yeah?
Yes, sir.
Okay, can you
Yes.
tell me what this can be replaced by? To clear air. I want to clear air. I should not model it. So I want it in terms of UR to be expressed if you can be any help. Could you please stretch your hand out?
Minus of UR.
So
Yes.
minus of your
Part into d theta by dt. Correct, yeah?
Yes, sir.
Yes, sir.
yes,
You
sir.
get clarity on the direction of du theta by dt now?
Yes, sir.
Yes.
Yes, sir.
Let us use it. D theta by dt and in which direction? Minus of UR. Okay. The other one, of course, we don't have any issue with. Okay, fine. Tell me, how many accelerations you are to get them from here? What are the directions which you are getting for the two components? One is in the direction minus of UR, the other is in the direction U, correct?
Yes, sir.
So one is in the direction minus of UR, the other is in the direction U theta, correct class?
Yes, sir.
Yes, sir.
Yes,
So
sir.
minus of UR as per our notation will be towards the center, yes or no? This was
Yes, sir.
UR, correct? And
Yes,
this
sir.
U theta, right here.
Yes, sir.
Yes, sir.
So minus of UR means what to us? Towards the center, correct?
Yes, sir.
Yes, sir.
Yes,
One is one of the acceleration component is directed radially inwards. Can we say that?
Yes,
sir.
sir.
And the other tangential, correct, dear?
Yes, sir.
So the
Yes, sir.
first one, as is directed radially inwards, is named radial acceleration. What is the first one named? Radial acceleration. And second one, as it is directed tangential, is called tangential acceleration. Find here.
Yes, sir.
So radial acceleration will be in this direction, and this will be for tangential acceleration. Am I clear, class? Am I clear to all of
Yes, sir.
you?
Yes, sir.
Total, of course, will be vector sum of the two, correct?
Yes, sir.
Total will be vector sum of the two. So this is about radial acceleration, tangential acceleration. Also, we know that radial acceleration is only AR. Now, can we write it as V into omega? Check it out.
Yes, sir.
Check here, V by dt is
Yes, sir.
omega, correct?
Yes,
So
sir.
V into omega, say yes or no?
Yes,
Yes,
sir.
sir.
Now to come to the more pronounced one. The more pronounced one are these. Tell me what you can replace V by. Can you say omega into R? Just now you have seen, you have
Yes,
established
sir.
this relation, correct?
Yes, sir.
Yes, sir.
Yes, sir.
What do we get from here to see? This is omega square R, fine?
Yes, sir.
Yes, sir.
Or if I want to change omega and write it in terms of V by R, can we?
Yes, sir.
Omega. Instead of omega, what we can use? V by R. Can we check it out here?
Yes, sir.
Then we
Yes,
get it
sir.
as, or in the form, V square by R, correct?
Yes, sir.
Yes.
So they are more pronounced than V omega, of course. One is omega square R and the other is V square by R. Fine?
Yes,
Yes,
sir.
sir.
These are the
Yes, sir.
equation for radial acceleration. And tangential acceleration depends on what is happening to a speed. See, radial acceleration cannot change its direction. A radial acceleration cannot change its direction, but tangential can. By that, what I mean? Tangential acceleration will be in the direction of velocity or will be in the direction of u theta if dv by dt is positive, correct?
Yes, sir.
If is dv by dt positive, by that what I mean? If speed is increasing with time. So tangential acceleration will be incommensurate with direction of velocity only if speed is increasing with time. Clear?
Yes,
Yes,
sir.
sir.
But if you are negotiating a circle with decreasing speed, if you are negotiating a circle with decreasing speed, of course you can, correct? Yeah.
Yes, sir.
Then dv by dt will be negative. And in that case, acceleration will be in the direction contrary to velocity. Clear, dear?
Yes, sir.
Yes, sir.
Okay,
Yes,
because
sir.
velocity is to be in the direction of u theta. You know that very well. That is what we began with, correct?
Yes,
We
sir.
began with the premise that v is equal to v into u theta, correct, dear?
Yes, sir.
Yes,
We
sir.
cannot backtrack. We cannot backtrack. We'll have to go with this equation. Okay? In that case, what we get to see, yes, AT can be in the direction of u theta only when speed is increasing with time. Else it will in the direction opposite to u theta. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Okay? So we cannot go back on V is in the direction of U theta. Fine, a question now. Can AR change its direction?
Yes, sir.
AT can. AT we got, yes, it can change its direction. Can AR is this. Can AR change its direction? Think about it. Think about it.
No, sir.
AT
It'll always be directed towards center.
because omega square R here, omega square cannot be negative, correct?
Sir.
Yes,
Yes, sir.
And R certainly cannot be negative. Are you getting it?
Yes, sir.
yes, sir.
V velocity, whatever it may be, V square will not be negative, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
And so will be R. Therefore, radial acceleration will always be directed towards the center. Clear, dear?
Yes, sir.
Yes, sir.
Tangential can be in the direction of velocity or opposite. Fine, dear?
Yeah.
Yes, sir.
Yes, sir.
Another question. Can we get tangential acceleration for any case? Can we get tangential acceleration to be a naught, a zero? Can we get it a naught, a zero?
Yes, sir.
When can we, Vedant?
Uh,
When can we read not for tangential acceleration? Can we read not for tangential acceleration or not? Is the first question. Answer
first-
this question.
So only,
Can we read for tangential acceleration or not? A zero. Yes, Krish.
so only velocity is constant. So, and velocity is not
Okay.
constant. Then
Velocity can never be constant.
constant. So you cannot.
Velocity when you're on a circular track can never be constant.
So it's not possible.
Okay, Adesh.
So yes, it's not possible.
Okay, Vedant.
so I think it's not possible. Yeah.
Okay. Velocity, why did you relate to? Did you collect my words? I don't think you collect my words.
So I
Have you
think
collected? I told it is the rate with which speed is changing with time. I didn't say velocity changing with time. When I circled it, I told it depends on whether speed is changing with time or not, correct?
Yes, sir.
yes, sir.
And when I
Yes,
told
sir.
you that you can very easily negotiate a circle, keeping speed in increasing mode, keeping speed in decreasing mode, or keeping speed constant, correct?
Yes, sir.
Yes, sir.
Yes,
You
sir.
can never negotiate a circle keeping velocity constant. But you can certainly negotiate a circle keeping speed constant, correct?
Yes, sir.
Yes,
So
sir.
if speed is constant, what will be dv by dt? What will be dv by dt? Mind you, this is not change in velocity. That is dv bar by dt. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
This is change in velocity, which can never be zero. This is change in speed. Can that be zero?
Yes, sir.
Yes, sir.
Yes, it can very well be zero. And so much so that we have a name for this motion. It is called uniform circular motion. It is called uniform circular motion. So a motion in which speed is not changing with time will get us AT equal to zero. Correct, yeah?
Yes, sir.
And if AT is zero, the motion is called uniform circular motion.
Yes, sir.
Can we ever get AR zero? Can we ever get AR zero? AR, radial acceleration. Can we?
AR.
Yes, I guess.
Okay, when can it be? Two cases, either omega zero or R zero, correct?
Yes, sir. So R
Yes, sir.
cannot be
R
greater.
is zero, you are no more on circular track.
Yes, sir. So when omega is
Omega
zero.
is zero, you are not negotiating the track, correct, yeah?
Yes, sir.
So radial acceleration can never be zero, correct? Yeah.
Yes, sir.
But tangential can very well be zero. Am I clear? Am I clear?
Yes,
Yes,
So
sir.
radial cannot be zero, but tangential can very well be zero. Yes, Krish, you are asking something.
No, sir, I'm not asking. Sir.
Okay, clear it? Is it clear to all of you?
Yes, sir.
yes, sir.
This is all we have in circular motion. Okay? Not a
Yes,
word
yes.
more. This is all we have in circular motion. Okay? We need to know acceleration, we need to know velocity. Of course, at times in question will be asked, what is the value of A total? So you know how to calculate A total, correct dear? AT plus AR, this will be the direction of A total, correct dear?
Yes, sir.
Yeah.
So
Yes, sir.
really at time this will be A total. Sometimes they will also ask what angle is making A total with AT. So that also is calculatable. Tan alpha we can calculate. What will be tan alpha? Tan alpha will be AR. This is AR, correct dear? So
Yes,
Yes,
sir.
sir.
AR, tan alpha will be AR by AT, correct dear?
Sir.
AR by AT. For yourself, right?
Yes,
sir.
sir.
Yes.
So those angles in question they may ask and we can solve easily the question. Shall I take one question which is in Euro on this or shall we go for the one that we are in? Rotational mechanics.
You can take the question, sir.
Okay, right, fine. Take the question right now.
So after this, can you show derivation of moment of inertia?
What did you say, Krish? What shall we go for?
So after this question, so can you derive moment of inertia for
Moment of
different
inertia
bodies?
for which one?
So different bodies, sir, like the basic ones.
Okay. Let's take a question on this quickly. Particle of mass m. A particle of mass m is positioned at the top of us at the top of a hemisphere moving with velocity v naught and with a speed decreasing with time and with a speed decreasing with time. If the radial acceleration if radial acceleration in magnitude is always equal to if radial acceleration in magnitude is always equal to tangential acceleration, if radial acceleration in magnitude is always equal to tangential acceleration, find equation for velocity as function of time. Find equation for velocity as function of time. The radius of this circle is known to you. Semicircle is known to you, class. Find here.
Yes,
Yes,
sir.
sir.
The radius of this semicircle R. Find here. And this semicircle is fixed. There is a particle which is initially at the pinnacle. Find here.
Yes,
There is
sir.
a particle which is initially at the pinnacle. Mass of this particle is m, and initially that is at t equal to 0. That is at t equal to 0. It is moving with velocity v naught. Find here.
Yes, sir.
Yes, sir.
Okay. And with advent of time, what is to happen to velocity? It is to decrease. Is it okay? With advent in time, what is to happen to velocity or speed rather? What is to happen to speed? It is to decrease. Find here.
Yes, sir.
Yes,
So
sir.
it will negotiate the circular track with decreasing speed. Are you getting it? This particle will negotiate the circular track with decreasing speed. Clear?
Yes, sir.
Yes.
Yes, sir.
Let us say at any point in time, particle is over here and its speed is v. There is one information which is being passed, and that being at any point in time, magnitude of radial acceleration is equal to magnitude of tangential acceleration, correct?
Yes, sir.
Yes, sir.
Yes, sir.
What you have to find? V. You have to find this V as function of time. I do question, find V as function of time. Find V as function of time. How can we find velocity as function of time? Think about it here. Make good of the information. There is data with you. Make good of the data. Can you? What is the information passed? There is an information passed. Can you glean on that information? Can we glean on that information? Can you tell me what did the author? The author did tell you something about radial and tangential acceleration, right? The author did tell you something about radial and tangential acceleration. What did he say? The magnitude
The
of
magnitude of radial
radial
acceleration is
acceleration is
equal
always equal to magnitude of
to
tangential acceleration. So what shall I write? Magnitude of radial is v square by r.
Yes, sir.
yes, sir.
Magnitude of radial acceleration is v square by r. Similar to now.
Yeah. Yes, sir.
Yes,
And
sir.
magnitude of tangential acceleration, is it dv by dt?
Yes, sir.
Magnitude of tangential acceleration, is it dv by dt? Say me yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
So can we say v square by r is equal to dv by dt?
Yes, sir.
Yes, sir.
Say Krish, v square by r is equal to dv by dt?
Yes, sir.
Yes, sir.
Okay. Yeah, now here you are to exercise cautious there. What did I write? A T to B. I asked you. I wrote A T is equal to dV by dt into u theta, correct?
Yes, sir.
If I ask you AT the mod, then you will write dV by dt the mod, correct?
Yes, sir.
Because u theta mod will be 1, that you know, correct?
Yes, sir.
So magnitude of AT is not dV by dt. Magnitude of AT is mod of dV by dt. Then you will
Okay.
ask me what's so big about it. I'll say this is something on which your answer will be linchpin.
Yes, sir. It's
Because
minus.
dV by dt can be either plus or minus of dV by dt, correct?
Yes, sir.
Agreed, sir.
Yes,
If
sir.
dV by dt is negative, then it will be replaced, mod will be replaced by minus, correct? Yeah.
Yes,
Yes,
sir.
sir.
And here dV by dt is negative. How we know that? Speed is decreasing with
Decreasing.
time, correct?
Yes, sir.
Yes, sir.
So what shall I do? Tell me now.
The v square by r is equal to minus dv by dt.
That's it. That is what was required. The rest you will be able to do. You know how to integrate. Right? Yeah. You know how to
Yes, sir.
integrate by variable separation method. dt by r over here. And over here you will be having dv by v square. Correct?
Yes, sir.
Yes, sir.
So this is integration of v raised to the power minus 2. Correct? Yeah.
Yes, sir.
Yes,
V raised
sir.
to the power minus 2 will be v raised to the power minus 2 plus 1 divided by minus 2 plus 1. Correct?
Yes,
From
sir.
where to where? V naught to V, and this from where to where? 0 to T, right?
Yes, sir.
Right or not? That
Yes,
yes
sir.
was not very convincing. Why so, Adesh?
Sorry, sir.
That yes was not very convincing. Why so?
So it was. I got it.
Find here, find to all of you.
Yes, sir.
Vedant.
Fine.
Yes, sir.
Okay, Krish.
Yes, sir.
Okay, so this was the question, and that is what we have taken, circular motion question. There are many a question, we'll be taking them later. For now, as being asked, let us also try to figure something that I have positioned for the day, and it being related to rotational mechanics. Fine, yeah. By
Yes,
the
sir.
way, let me conclude this question with what did I, Rudolph, qualify this question with? There's a supplement to this part. and the supplement being also find speed as function of s. S is the distance that it slipped. Okay. Also find velocity as a function of s. S is the distance by which it slips. Okay, dear?
Yes.
Sir.
Yes, sir.
And that also is easy, not difficult. Just over here, you have to make a change. What is it? dv by ds into ds by dt.
Yes, sir.
Yeah?
Yes, sir.
dv by ds into ds by dt. And then ds by dt will be written as v. Clear?
Yes, sir.
So we get it as v square by r equal to minus of v into dv by ds. Now you integrate, you'll get as a function of s. You'll get v as a function of s. Clear here?
Yes, sir.
Yes, sir.
Yes, sir.
Now as we are in vectors, we are through vectors rather, and we have seen relative motion few classes ago. Correct, yeah?
Yes, sir.
Yes, sir.
We saw relative motion few classes ago. We were in relative motion portion. So I am to conclude this part by one question which amalgamates concept of vector and relative motion. Is it okay?
Yes, sir.
Yes, sir.
And which amalgamates theory, vector and relative motion. Write it down. Two particles with position vectors r1 and r2 and velocities v1 and v2. Two particles with position vectors r1 and r2 and velocities v1 and v2 collide. Find relation between V1, V2 and R1, R2. I read of question. Find relation between V1, V2 and R1, R2. So particles are given to collide. There I am not to grow my brain. How will they collide? What manner they will collide? Author rests my concern in peace. Author rests my concerns in peace by saying that they are to collide. Find ya?
Yes, sir.
Yes, sir.
You can show velocity in any direction. Please don't take it true to scale. I'm just showing it this way. V1 here, V2 here. But yes, they are to collide. Find ya?
Yes,
You
sir.
are to find the relation between V1, V2, R1, R2. Tell me how can we write a relation between V1, V2 and R1, R2. This is y-axis, let's say this is x-axis. Tell me class, very simple observation, you must have made an observation. Must have, that I repose faith on you. That if you are to be, God forbid, hit by a ball, suppose if you recollect the time, any instance of being hit by a ball or any particle, then that particle appeared to you coming straight heading for you, correct?
Yes, sir.
Yes,
Isn't
sir.
it? That particle appeared to you coming straight towards you, heading for you, correct? Yeah?
Yes, sir.
Or you saw that the particle was going past you. If the particle was to go past you, you will not be hit by particle, correct? Yeah?
Yes, sir.
Maybe
Yes,
Yes,
sir.
sir.
if you are hit by a particle, then you will find that particle heading for you, correct? Yeah?
Yes, sir.
Yes, sir.
Now I ask you, sit on one of the two particles. Sit on A or B. Sit on one of the two particles. So if you sit on A, let's say you are sitting on A, then what will be the direction of velocity of B with respect to A? The moment you sit on A, you assume A to be at rest, correct?
Yes,
Yes,
sir.
sir.
When we sit on a particle, we are not qualified to register translational motion of that particle, or for that matter, rotational, but we don't relate rotational motion to a particle. You know that very well. Moment of inertia will be zero, correct? Yeah.
Yes, sir.
Yes, sir.
So translational motion, if I'm seated on a particle, then translational motion of that particle, I don't qualify a register, correct?
Yes, sir.
Yes, sir.
So I'm on this particle, and I know that B is to hit me, correct?
Yes, sir.
I know that B is to hit me. So if B is to hit a particle, then B should head towards the particle. Are you getting it? Think of the
Yes,
concept.
sir.
One particle is at rest and the particle is in motion. When can they realize collision? And what kind of collision will it be? It will be only head-on collision, because that particle which is in motion will have to head for the particle which is at rest. If it doesn't head for the particle which is at rest, then it will miss the particle. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
That would directly head towards the line joining the two particles. Say me yes or no.
Yes, sir.
Yes, sir.
Repeating it. Adesh,
Yes, sir.
I am at A Adesh. So if I'm at A Adesh, then I'm at rest, correct?
Yes, sir.
I'm calculating velocity of B with respect to A. Means with respect, the moment there is with respect, then that particle is ought to be at rest. That is clear or not, Adesh?
Yeah, yes, sir.
I say velocity of A with respect to B, then where I am? I'm on A or B?
So you're on A, which is at rest.
Oh, no, no. Velocity of A with respect to B, where I am? Please read it properly, Adesh. Velocity of A with respect to B, where I am, A or B?
You're on B and B is at rest and you're looking at A.
Yes, I'm looking at A. But where am I? I'm on B, correct?
Yes, sir.
And if I'm on B, will I register motion of B?
No, you will register motion of A from B.
Yes. So I'll register motion of A, and that motion will be read as velocity of A with respect to B, correct?
Yes, sir.
So one of the two particles which I am on is at rest, correct, yeah?
Yes, sir.
Yes.
So if the other particle is to make a collision, then other particle should follow the line joining the two particles, correct? Should head
Yes.
directly towards it. Are you getting it?
Yes, sir.
Because particles are dimensionless. Same will not happen for a body. A body can be hit obliquely as well, correct, yeah?
Yes, sir.
Suppose dimension over here, Adesh, then you can hit it this way as well, correct? This way
Yes, sir.
as
I
well.
got it. Yes, sir. I got it.
But if dimension is zero, then you'll have to head towards it, correct?
Yes, sir.
When I say particle, what I'm referring to is a body of negligible dimension. Clear?
Yes, sir.
So, in which direction should be velocity of B with respect to A? Line joining B and A. Can I say that?
Yes,
Yes.
sir.
Get down. Velocity of B with respect to A should fall on the line joining points A and B.
Yes, sir.
Points A and B. If this is clear, question stands solved. If this is clear, question stands solved. How? Velocity of B with respect to A. Velocity of B with respect to A. What is that to be written? VB minus VA. Correct, yeah?
Yes, sir.
Yes, sir.
It can also be marked as in terms of 1 and 2. It can also be marked V2 minus V1. Yeah?
Yes, sir.
Yeah?
Yes,
Yes,
sir.
sir.
Okay. Now V2 minus V1 is in which direction? That also is known to you, correct? Yeah?
Yes, sir.
Yes, sir.
Can you tell me a vector in terms of R1, R2 in this direction? Can you tell me? Let me stretch my argument and ask you. Can you tell me the yellow one? Look at the yellow mark now. Okay. Can you tell me what this vector can be written in terms of R1, R2?
So R1 minus R2.
Okay, R1 minus R2, sure. I think he's
Yes, so you
correct.
reverse R.
This is 1. So either you can write 2, 1 vector or you can write R12 vector. Correct, yeah?
Yes, sir.
Yes, sir.
Okay, so R1 minus R2 is the vector, that vector, correct?
Yes, sir.
Yes, sir.
Now, can I say V2 minus V1 is equal to R1 minus R2? Think about it before saying yes or no to it. Think about it. Can I say V2 minus V1 is equal to R2 minus R1?
So 1 second.
Think about it.
Yes.
See, R2 minus R1 on dimension or length is known to me. This will be the length, correct?
Yes, sir. Yes, sir.
Yes, sir.
But am I sure of the length of V2 minus V1? I
No.
don't know.
Yes,
I'm
sir.
not sure on the length of V2 minus V1. R2 minus R1 I know. But V2 minus V1 I don't know. So in order to make it free of length, what shall we do? We shall divide them by their magnitude, correct?
Yes, sir.
If you divide
Yes,
them by their magnitude, then you are absolving yourself of length. Reason, they
We
will
get
both
unit vector.
unit on length, correct?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the relation. V2 minus V1 by mod of V2 minus V1 is equal to R1 minus R2 by mod of R1 minus R2. Clear, dear?
Yes, sir.
Yes, sir.
Yes, sir.
This is the kind of question which I was referring to. Now let us take few moment of inertia calculation as per what Krish did ask. I begin with, write down. Let us take a rod of mass m and length L. Let us take a rod of mass m and length L. Calculate moment of inertia. Calculate moment of inertia of this rod. Calculate moment of inertia of this rod about an axis passing through one of its ends. About an axis passing through one of its ends. So length of rod taken is L class and M is the mass. Is it okay?
Yes, sir.
Yes, sir.
And this is the axis passing through one of its ends and perpendicular to the plane of rod. Clear, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
Come to the other axis as well. But to begin with, I have taken this axis. Fine, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
So if this is the axis and I have to calculate moment of inertia, I am known to moment of inertia means mi square. Remember, we took ri prime and I told you that prime is the perpendicular distance from the axis of rotation, correct?
Yes, sir.
Yes, sir.
So that being the only formula, I'll have to smither it. I'm into smithering and take a particle of mass dm. Find, yeah?
Yes,
Yes,
sir.
sir.
And dm at what distance? At a distance, let's say x, right?
Yes, sir.
Yes, sir.
Tell me small amount of moment inertia will shape to what? dm into x square, right here.
Yes, sir.
Yes,
dm is the mass, it's a particle, and x is the distance, perpendicular distance, right here. So
Yes,
dm
sir.
into
Yes,
x
sir.
square, and then we have to find I. So what will be I over here when we integrate dm into x square, correct?
yes, sir.
What
Yes, sir.
distribution is this? Linear. So we can write dm as lambda into dx. We can count on that. Can we?
Yes, sir.
dm can also be written as lambda into dx. Where what is dx? The length, the small length. Clear? This is
Yes,
dx. Clear? And what is lambda? Lambda is mass per unit length. Correct? Linear density. Clear to all of you?
Yes,
Yes,
sir.
sir.
Clear, Adesh?
Yes, sir. Yes, sir.
Okay. So what do we get from here? Mass is m, length is l, they are out. Integration of x square will get me x cube by 3, correct?
Yes, sir.
Yes.
From where to where x will vary? 0 to l, correct?
Yeah.
Yes.
Tell me
Yes,
what
sir.
we end up getting. What we end up getting, see for yourself. What is it? What is the value?
Sir.
ml?
Sir, ml square by 3.
Yes, ml is square by 3. Area. So moment of inertia for a rod about an axis passing through its center. What will it be?
ml
Square by
square
3.
by
ml square by 3.
Now tell me by using parallel axis theorem, what will it be about center of mass? Come on, quickly.
So,
What will it be about center of mass? Come on, tell me quickly. Parallel axis theorem. Use parallel axis theorem. You can calculate otherwise as well, but I'm asking you to use parallel axis theorem. Length of rod is L, mass M. Come on, class, quickly. Use parallel axis theorem and let me know what will be moment of inertia about an axis passing through its center and perpendicular to the plane of figure.
so will it be ml square by 12?
Yeah, very good. It'll be ml square by 12. ml square by 3 plus ml square by, what will you say over here? D is how much? L by 2?
Yes,
Oh, yeah.
sir.
Yes, sir.
yes, sir.
Yes, sir.
Okay, by that process, you will get it as what said Vedant, ml square by 12. If you want to go by this process, then you'll have to change the limits. See, you will take the axis here, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
And then again, you will take a small segment at a distance x, everything the same. But the integration limit will change from where to where? From minus of L by 2 to plus of L by 2, correct?
Yeah,
Yes,
yes,
sir.
sir.
Yes, sir.
Okay, and then you will get the same end result, ml square by 12. Fine, dear?
Yes,
Sir.
sir.
Yes.
Okay, so that is what we get for a rod, linear rod. Clear? Linear
Yes, sir.
rod. I have not taken the other dimension. There is only one dimension which we are associating with it. Fine, dear?
Yes,
Yes.
sir.
Okay. Next we take for a ring right now. A ring of mass m radius r. A ring of mass m radius r. A ring of mass m and radius r. So this is the ring. Mass of ring is m, radius is r. Tell me it is easier one out. I'll say this is easier one out. Tell me how will I write for a small part, di. Di means I'll have to break it into small parts and look for what will be di for this part. Correct, dear?
Yes,
Yes,
sir.
sir.
Axis, about this axis. I have taken this to be the axis, again perpendicular to the plane of figure, correct?
Yes,
Yes,
sir.
sir.
Okay. What is the perpendicular distance? Nothing but r, correct?
Yes, sir.
Yes, sir.
Mass is dm, and dm will be multiplied with r square. Find here.
Yes,
Yes,
sir.
sir.
When I am to integrate, integration will simply fall on dm because r square is constant, right?
Yes, sir.
Yes,
Yes,
sir.
For
sir.
any particle r square will be constant, so it falls on dm, and dm when integrated will get me mass,
mr
correct?
square. mr
So
square.
what will
Yes, sir.
be mr
Yes, sir.
square, correct? So
Yes,
what will
sir.
be
Yes.
I of inertia about this axis? It will be mr square, correct?
Yes,
Yes,
sir.
Yes, sir.
Now tell me what will it be about this axis? What will it be about that axis? What will it be about this axis? Come on. You can tell me. You can tell me. Use perpendicular axis theorem.
Yes, sir.
Use perpendicular axis theorem. What can you say about this and about this?
Square by 2.
Sir, will it
MR
be
square by 2.
Suppose this is I1 and this is I2, correct? Yeah?
Sir, it's MR square by 2.
I1 plus I2 is equal to MR square. Can we?
Yes, sir.
Yes, sir.
Yes, sir.
And be perpendicular. Got it here? Try connect.
Yes,
Join
sir.
the dots. I'm just placing 2 and 2 together, nothing much. Am I clear?
Yes,
Yes, sir.
sir.
Okay, so I1 plus I2 will be equal to about this axis, clear?
Yes, sir.
And also by symmetry, you can say I1 will be equal to I2. By
Yes,
symmetry,
sir.
you can say
Yes.
I1 will be equal to I2. So twice of I1 or twice of I2 is equal to MR square, right?
Yes,
Sir.
sir.
Yes, sir.
So I1 is equal to I2 is equal to MR square by 2, right? Yeah.
Yes, sir.
Yes, sir.
This is how you will calculate moment of inertia about any axis. Find yeah.
Yes, sir.
Yes, sir.
Yes,
What's
sir.
the time? What's the time?
So
So,
220.
280.
220.
2:20. Okay. 2:20. What time did we start?
12:45.
Yes, sir. One.
Okay. Now let's go to our disk now. Write down. Let us take a disk. Let us take a disk of mass m and radius r. Let us take a disk of mass m and radius r. Find moment of inertia. Find moment of inertia about an axis passing through its center and perpendicular to the plane of disk. Find moment of inertia about an axis passing through its center and perpendicular to the plane of disk. Okay, what we are taking next class? We are taking next a disk. And for disk, we'll make good of what we studied for ring. Yeah?
Yes, sir.
Yes, sir.
I take an elementary ring of radius zeta and thickness d zeta. Fine.
Yes, sir.
Yes.
Okay. Then what is moment of inertia of this ring? Now you know. Moment of inertia of this ring will be mass of this ring into zeta square. Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Mass of this ring can be written as mass. Now, what kind of distribution is this? This is surface distribution of mass. Can we say that?
Yes, sir.
So,
And
what?
surface distribution, if you have taken, then you'll have to take area because surface distribution relates to sigma, and sigma when multiplied with area will get you mass, correct?
Yes, sir.
When you take linear distribution, then you relate it with lambda, correct?
Yeah. Yes, sir.
And physics used to get you mass, remember? Can you recollect? dm I used to replace by lambda into dxy because the distribution was linear then, correct?
Yes, sir.
Yes,
Here the
sir.
distribution is surface. So dm will be replaced by surface distribution into area, correct?
Yes, sir.
Yes.
Correct, Adesh, Vedant?
Yes, sir.
No, you're not sounding confident. Why so?
So what is that zeta?
Yeah, the radius. It's
Okay.
radius notation. You can take it as small r.
Yes, sir. Yes, sir.
Okay. Yeah, Adesh, what makes you go Miki?
Sir, no, sir, I got it. No, sir.
Sigma into dA will be dm. Now sigma is referred to, if you know good, if you don't know, write it down. A sigma means mass per unit area, which is also called surface density. Mass per unit area, which is also called surface density. Is it okay?
Yes,
Yes,
sir.
sir.
Okay. Now, what will be dA replaced by? dA, why I require? Because I have to get dm. And dm, how can I get? When I multiply mass per unit area with area, correct?
Yes, sir.
Yes,
Now,
sir.
I want area. I want area to be associated with this elementary ring. So first of all, what will be perimeter of this ring? 2 pi zeta. And what is thickness? D zeta, correct?
Yes, sir.
Yes,
Yes, sir.
Perimeter is 2 pi zeta and thickness d zeta. So 2 pi zeta multiplied with d zeta will get me the small area, correct?
Yes, sir.
Yes, sir.
Okay. So 2 pi zeta d zeta. Done. This is for area, correct?
Yes, sir.
Yes, sir.
Theta square is for
Yes, sir.
perpendicular distance square, correct?
Yes,
Yes,
sir.
sir.
Yes,
Now
sir.
what you have to do, you know very well. Integrate it from where to where? From zeta equal to
0
0 to zeta equal to capital R, correct?
Yes,
Yeah.
sir.
Yes,
Yes, sir.
sir.
Please do the needful. Tell me what are you getting? You can replace it. You can replace sigma. Sigma by n divided by pi r square. Finally, correct? Yeah.
Yes, sir.
Yes.
Okay. Please do the replacement and get know on what it is shaping to. Tell me, any one of you, what did you get?
Yes, 1 second, sir.
So 2 pi and sigma will be out of the integration. They are constant now.
Yeah, they are constant. They will be out of integration, right? Yeah, right. Vedant? They'll be
Sir,
out
I'm
of
getting
integration.
R
Just
square by
integrate it.
How much? MR square?
2.
Very good. That is the answer. That is the right answer. It is equal to MR square by 2. That is what you will be getting finally. MR square by 2. And you know, class, whatever we did for ring is what you are to do for hollow cylinder. Clear?
Yes,
Yes.
sir.
Whatever you did for ring, exactly the same you are to do for hollow cylinder. So whatever you get for ring, you get for hollow cylinder. Clear, dear?
Yes, sir.
I have one
Yes,
doubt,
sir.
but
Yes, dear. What did you ask, Adish?
so I have a doubt. So in a hollow cylinder, so we can't get sigma, right? Because sigma is mass per unit area.
Very viable doubt. Very viable doubt in hollow cylinder. If I am to take it akin to ring, then what makes me justify lambda is your question. Correct, dear?
Yes, sir.
Correct, dear?
Yes, sir.
So what
use
makes
lambda.
me justify lambda is very simple, in a very simple statement to be answered, that I am taking multiple rings and they are stacked. Is it okay?
Yeah.
I took one ring as this and it is of mass dm. Over it another ring and it is of mass again dm. Is it okay?
Yes, sir.
For
Yes, sir.
each such ring, I get moment of inertia as dm into r square. There is no confusion, I presume.
No confusion.
And when you take all the rings, then basically you are adding mass. Correct, dear?
Yes,
Yes,
sir.
So mass will get added. Right, dear?
Yes, sir.
Yes,
And mass will get added to get you total mass of cylinder. Correct, dear? Because
Yeah.
when you stack
yes,
rings,
sir.
you get cylinder. Correct?
Yes, sir.
So for cylinder, hollow cylinder, it'll be similar, exactly but similar, spitting image of what you get for ring. Here you say about an axis passing through its center. There you will say about its axis, because cylinder has got an axis to its merit, correct?
Yes,
Cylinder
sir.
has got an axis to its merit, correct? So that will be about
Yes.
its axis, clear?
Yes, sir.
And what about solid cylinder in accordance? Will
So we
be the
use a
same
So
as this.
disk. So yeah, disk.
Yes, it'll be the same as this,
Disk.
which is MR square by 2. Clear, dear?
Yes, sir.
Yes, sir.
yes, sir.
Here we are justifying what we have used previously. I told you that take it on face value MR square by 2 MR square, isn't it, dear?
Yes, sir.
Yes, sir.
We have justified what is moment of inertia for a ring, for a for a disc, and for hollow cylinder and solid cylinder. We have not yet for shell and sphere, correct?
Yes, sir.
Yes, sir.
I ask you to give a shot for them.
Yes.
Tell me, what will you do for a shell? How will you go about when is asked to define moment of inertia for a shell? What shall you do?
Is it made up of element like rings stacked one
Yeah,
upon?
made of element rings, but this time of variable radius. It is not the same as that of cylinder, right, dear?
Yes, sir.
So variable radius. Therefore, you will have to take theta as well to write radius of that ring. And then we'll execute integration. Clear?
Yes, sir.
Yes, sir.
So I'll leave it for you to try for shell and sphere, and also will ask you to search on internet a theorem which is called Pappu's theorem. Pappu''s. Pappu's theorem. This is a theorem which is difficult to find even on internet, but just give a try. And this theorem will help you in calculating moment of inertia for many a structure. Okay? And please, when something being revealed to you in class and is incognito to be kept, try to keep it to yourself. Okay?
Yes, sir.
If
Yes,
someone
sir.
asks, I will be bound to explain. But unless and until someone asks, there is no need to go to town telling everyone that I know this, I know that. Okay?
Yes, sir.
Yes,
Don't
sir.
shoot your own foot. Clear, dear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so shall we keep to this today, class?
Yes, sir.
Yes,
Yes,
sir.
Okay, thank you, dear. Thank you, all of you.
Sir, is
Thank
it
you, sir.
sir,
Thank
one
you,
small
sir.
question?
Uh-huh.
There is the name Pappu's centroid theorem.
Pappu's centroid, correct. It's not centroid, we don't call it here. Pappu's theorem only we call. We rotate the body here. What we do that we rotate a body. Suppose you rotate a ring.
Yes,
Then
sir.
when you rotate ring, you get shell. So if you know center of mass of ring,
Yeah, yes,
then
sir.
you can find moment of inertia of shell.
Okay, yes, sir.
Okay,
Yeah.
so that is the relation. That's the reason I'm asking you to go through it. We
Sure,
will be
sir.
solving questions on it, don't worry. Okay?
Yes,
Yes,
sir.
sir.
Just take a read. Okay, Krish?
Thank you, sir.
Pappu's
Yes.
theorem.
Yes.
That relates, just check if they are adding centroid to it. Though centroid, I don't think, because that doesn't, to me, ring. It is no centroid supplemented with. It is just Pappu's theorem.
Yes, sir.
It relates center of mass with moment of inertia. That's it. When you rotate the body. When you revolve the body by 360 degree, then it relates